Hello, my name is Sandy Chim, President and CEO of Sentry Global Commodities. We are an iron ore development company with a project with projects in Canada. Our most advanced project is called Joyce Direct Shipping Ore Project, which has a feasibility study published in 2015, available on CEDAR. We have a net present value of Canadian dollars 524 million after tax at 142 US dollars of iron ore price, which is trading about $170 today. Let me bring up the presentation to your screen and share with you with some more details. Joyce Lake is located in the Labrador Trough in Shefferville. It is about 43 kilometers away from the railhead in Shefferville, and Shefferville is about 600 kilometers away from the Port of Seattle, which is the Four Seasons port. Rail is connected, port is in operation, the entire infrastructure services the region of a number of mining companies. Mostly they are global major mining companies and steel makers. And these infrastructure has been in operation for the last 70 years. We are located just 43 kilometers away from Shefferville. Joyce Lake has a feasibility study, and this feasibility study defines 18 million tons of about 60% Fe content of iron ore reserves. Most of the reserve is actually at about 61 to 62%, which is the standard market shipping grade. And we have about 14 million tons of that out of 17 million tons of reserves. The operation is very simple. It's only a quarry operation because it's direct shipping. It involves only mining and crushing and screening. And we have the final product. So in the mine, we're talking about 2.5 million tons a year of mining rate by design of the 17 million tons of reserve. And out of the initial 5 years of operation, we'll finish the high grade 62% Fe content material and ship them to the market as quickly as possible, rather than stretching the entire mine life in order for us to catch the better part of a cycle like what we're seeing today. In terms of costs, what you're seeing there, basically feasibility study estimates, mining cost wise is about $14, processing about $2.25, with another $5 G&A, we have the final product. And we just going to load the final product in the form of sinter fines and lump ore onto trucks and haul the material 43 kilometers to the railhead and load the products into a train, railing about 565 kilometers. Trucking cost is about $3.50. Railing cost is about $24. Port cost is about $10, all Canadian, totaling about 58 Canadian dollars FOB per ton in total. Translated into US dollars, about $47 per ton. Shipping to China is about $15 US. So we're talking about landing in China about $60, $65 compared to where the market is today, $170. There is close to $100 per ton. And the capital intensity of this project is very low. It is only $12 US per ton. So if we factor in what we're talking about, the $60, $65 per ton landing cash cost, adding capex to it is about $75 to $80. When the market again is trading about 160, 170 US dollars per ton. In terms of infrastructure, the rail has been operating for a number of years. Is a common carrier, meaning that the rail operator has to carry our ore at market rate. At the port, the IOC port is available for service. Been working with a number of other operators over the years, but the new port actually was finished and completed in 2018. Adding another 50 million tons of capacity with 2 loaders at the same port at Pont Noir, very close to the existing IOC port. So the infrastructure is mature, operating. There's no problem of constructing or building very large scale, high capital intensity infrastructure to support the operation. The operation will be supported by existing common infrastructure in the area. I'm showing you the summary from our feasibility study, the CapEx and OpEx. As you can see, it's a very simple operation. You saw the $58 per ton Setil FOB, Canadian dollars translated into US dollars is about 46. Capital cost wise is about 11 US or to $12 US per ton, and it's very low capital intensity spread on the 18 million tons. The total capex is $260 million. Most of that actually goes to infrastructure. As you can see here, more than half of the $260 million cost on new infrastructure is costed in the feasibility study, roughly about $126 million, as you can see, infrastructure here, plus the vehicles cost and rail cars and trucks. And the mining part is only about $60 million of stripping the mine, and the plant with mobile equipment bought new, and mine servicing is about 29 million, close to $30 million. On the per ton economics, if I can put that in perspective, in comparison to where the market is trading today, about $170, we have, according to our base case in the feasibility study, if we were to sell the product at 95 US dollars per ton, there is substantial cash flow because our OpEx per ton is 46, 47, sea freight is about $16 plus some premium penalty. We actually are generating at this $95 per ton base case a cash margin. We generate a cash margin of 32 US dollars before capex. If we pay for capex every ton, then we got $20 per ton margin, and therefore with those margin, we designed the plan, the feasibility study, to operate 2.5 million tons, and therefore quickly capturing the initial year's cash flow in an opportunistic and high cycle timing of the market. And therefore, in that scenario, only at $95, we're generating $400 million of cash flow over the first 5 years of mine life. If we are extending the feasibility study to cover another scenario of $142 US, which is still very much lower than the $170 we're looking at today, we are generating an additional $600 million cash flow more in the 5 years, in addition to the $400 million US that we're talking about. So this project is designed to capture the better pricing of a cycle, and this is what we are. We are at the beginning of a new cycle, and therefore the per ton economics running at the highest possible mining and operating rate can deliver us that cash flow. In summary, just summarizing what we've been talking about, according to the feasibility study, 2.5 million tons on 18 million tons of reserves and $260 million of capex per ton is about 12 US dollars, and FOB cost is about 46 US dollars. With construction time, because it is very simple quarry operation, it takes only 1.5 years from beginning to put a shovel on the ground to completion of construction. It's only 1.5 years, and it's got a 5 years of high grade mine life to 7. In the market, we can lock up in the futures market up to 4 years of futures contract to guarantee that most of the 5 years can be locked up when we see the opportunity for the market is there to lock up and write up to 4 years contract, making sure that we get revenue favorable to the project. And according to the feasibility study, we have a very high financial KPIs at, again, $142 US per ton of price assumption. We have Canadian dollars, $524 million of net after tax present value, compared to base case, which is $95 when we are trading almost doubling the base case scenario, and therefore the $500 million of NPV value is looking very achievable in today's market terms. In terms of roadmap, we have between now and the beginning of construction, which takes about 1.5 years, is about 12 months. We got a feasibility study, I said, published in 2015, which is still pretty good, but we have come up with certain optimization ideas that we would like to include in a new updated feasibility study to confirm those ideas, to cut even OPEX and CAPEX. And we're going to use that time for the next 12 months in terms of environmental impact statement we have already done, but to update it, to negotiate IBA, do some geological drillings, and then we're in a permitted stage 12 months from the beginning of embarking on the updating of these studies and the permitting process. In summary, the project is in the right cycle. It is the beginning of the cycle. For a short project designed to capture the better part of the cycle, this is where we are. And the project can achieve that because it's got high grade, short mine life, very low capital intensity, very short time to build, about 1.5 years of construction time. And therefore, we've got a very good match between our project and the cycle, making it very attractive. I hope you enjoyed this presentation. Hope you find this project interesting. If you are interested in talking to us and discuss more detail about the project, please reach out to us through the platform that you're watching this video on, and we'll get back to you. Have a good day.